What are the best practices for avoiding ISR stack overflow? Imagine your microcontroller is a busy city, and the interrupt service routines are the emergency responders rushing to handle crises. If too many emergencies happen at once or responders get overwhelmed, chaos can ensue. That chaos is similar to what happens when an interrupt service routine causes a stack overflow. The stack is like a small memory space used to keep track of where the program is and what it's doing during interrupts. If it gets too full, it can overwrite important data or cause unpredictable behavior. So, how do we keep our microcontroller city running smoothly without overflowing the ISR stack? First, you need to figure out how much stack space your interrupt routines might need. Think of it as estimating how many emergency responders might be needed at once. You should analyze all the functions called within the interrupt and include nested interrupts if they are enabled. Once you have this estimate, allocate enough stack memory with a safety margin. For example, if your worst-case scenario needs 2 kilobytes, allocate at least 3 kilobytes to be safe. Next, keep your interrupt routines short and sweet. Avoid writing complex code or using large local variables inside the ISR. Large variables or heavy processing can quickly eat up stack space. Instead, do minimal work in the interrupt and defer heavy tasks to the main program or lower priority tasks. For instance, just set a flag or store data in a buffer during the interrupt, then process it later. Avoid calling functions that use large stacks from within your ISR. Every function call saves register states and local variables, which adds to stack usage. If possible, write small, simple functions or use software interrupts if your microcontroller supports them. This reduces the stack load during an interrupt. Monitoring the stack during runtime is another smart move. You can set aside special memory areas called guard zones next to the stack. If the guard zone gets overridden, it signals an overflow. Some microcontrollers have hardware features like stack limit registers that generate exceptions if the stack pointer crosses a predefined boundary. Enabling these features helps catch overflows early. Organizing your memory layout also helps. Place the stack in a part of memory where an overflow won't corrupt critical data. For example, if your stack grows downward, position it at the top of RAM. That way, if it overflows, it hits a protected area or triggers a hardware exception. Defensive programming is key. Use static analysis tools to check your code for potential stack issues. Test your system under worst-case interrupt scenarios to see if your stack size is enough. Keep your interrupt nesting depth low by prioritizing interrupts and disabling nested ones if possible. This reduces the chance of your stack filling up quickly. Combining these practices creates a solid shield against stack overflow. For example, you might allocate ample stack space, keep your ISRs minimal, enable hardware stack limit features, and regularly check the stack during operation. This layered approach ensures your microcontroller handles interrupts reliably without risking a crash.